Welcome to this other lecture on digital computer electronics. We are again discussing circuit algebra or switching algebra, which is studied under the title Boolean algebra. But this time we are not minimizing using Boolean laws, but we are using a technique called Karnaugh maps. So let's start with the minimization using Karnaugh maps. We'll start with expressions having two variables. Let's consider expression y equal to ab or a naught b or ab naught. This expression can be realized by this circuit consisting of 3 2-input AND gates, 1 3-input OR gate and 2 NOT gates. We can minimize this expression simply by using Boolean laws. If we OR one more AB to this expression, it will be AB or A naught B or AB naught or AB. So then if we take B common from the first two terms and A from the last two terms, we can solve this expression. It will be a simple y equal to A or B. But how to solve this expression using Karnaugh map? We can just express this relation, this expression, with the help of two variable Karnaugh map. A variable represents columns, first column, left column A naught and the right column A, and in similar way B represents the rows, B naught as the first row and B as the second row. So all these terms have their own cells in this Karnaugh map. AB has the corner bottom cell in the right, so it is 1. Again A naught B is having the bottom cell in the left, and AB naught is having the cell in the first row on the right hand side. So we have now 3 ones in this expression, and the fourth term which was possible in this type of expression, that is absent. So that is A naught B naught, that is not present here, so that expression is represented as 0, means that term is absent. Now how to minimize? We generally make the pairs or chords or octets of the ones in the Karnaugh map. So we can pair like this. If we combine the vertical ones on the right hand side, we see that they are a column, and B naught and B will be vanished, so the variable, only the column variable will remain, that means A. So this pair now represents only A, and we can have the second pair in the same way, which is a horizontal row in the bottom, which actually represents B, and A and A naught vanish. So this expression by is minimized by this Karnaugh map by having only two pairs covering all ones. So the simple solution is A or B. So if we implement it, it is a simple OR gate. Let's move forward. Take a Karnaugh map and understand it. This is Karnaugh map of two variables in which all the cells can have three types of variables. There can be a 0, means the term is absent in the expression. There can be 1, means the this term is present. Term is present in the expression. And if there is X, that means is a do not care condition. Means this term can be taken as a 1 or a 0 according to your own choice. We'll we'll use this do not care in the later on expressions which will be solved here. Now let's take an example again in this two variables again, and we'll see that the Karnaugh map representing this is having 3 ones and 1 0, because only one term is absent. That means A B naught is not there. So in place of A B naught we write 0. Now we'll make the pairs in the same way. So if we make this pair, this represents A naught, and the next pair represents B. So this is minimized. Let's take the example of 3 variables. So the 3 variables will be handled by a 3 variable Karnaugh map, and 3 variables we know can have 8 maximum terms. So this sort of expression is solved by the Karnaugh map having 8 cells, and the 8 cells can be either having 2 variables in the horizontal and 1 variable in the vertical, or 2 variables in the vertical and 1 variable in the horizontal. I have put here a Karnaugh map of 8 cells with 2 variables in the horizontal and 1 variable in the vertical. So if we see all these terms, they represent these 4 ones, and I have made the pairs also. And if I see the pair which is vertical 1 pair in the center, in which AB is on the top, and C and C naught will vanish in this case. So one variable will go, because it is a pair only, one variable will go. So this will represent simply AB. And if we see the bottom left pair, in that on the left side we have the C variable, but on the upper side A and A naught will go. So B will remain in the horizontal direction, in the vertical direction, and C will remain in the horizontal direction. So we'll have BC for this pair. And if we see that pair which is the bottom right pair, for that B and B naught will go and A will remain and C will be on the row side. So if we see what is the solution of this expression, it is y equal to AB or BC or AC. and then we can implement it with a simple circuit. This is the circuit. So we can forward from this and have another example of 3 variables. Now I'll take an expression like this, that expression y equal to a naught b naught c naught, or a naught b naught c, or a b naught c, or a naught bc, or a bc. If I check this a naught b naught c actually means 0 0 0. That means all zeros means represents a 0 term. And then if we see the second, it is 0 0 1, it represents 1. And if it's a b naught c, it is 1 0 1, it represents the 5. And in the same way, 0 1 1 represents 3 and a b c represents 7. If I draw the Karnaugh map, you see, if I check according to what is the place of the variables in this Karnaugh map, we'll see that the variables are actually representing in AND or represent the cells. So I can say that all these terms can be placed inside these as ones, and whatever terms are not present here will be placed as zeros. And you see that in the corners of the cells it is written that what cell actually this represents. I have written in the corners in black 0 1 3 2, then 4 5 7 6. These are the cells representing different terms. So if we now pair, we'll have a chord. We first try to see that 4 ones are together and we combine them and we make this called chord, because I'm having the 4 ones. So what a chord does is that it vanishes 2 variables. One, this type of square chord vanishes 1 variable in the horizontal and 1 in the vertical. So A and A naught will go and B and B naught will go. For this chord, the minimization is only C. And then only 1 remains that can be paired again, and you know that in the pair only 1 variable goes, so it will be C and C naught will go, so it will be A bar in the column and B bar in the row, so it will be A bar B bar. So it is solved. The minimizer expression is A naught B naught or C. So let's start with the minimization using Karnaugh maps with 4 variables. This is a Karnaugh map which represents 4 variables, 2 variables in the vertical and 2 variables in the horizontal. So if CD represents the column variables and AB represents the row variables, then the first cell will be A bar, B bar, C bar, D bar, or we say A naught, B naught, C naught, D naught. That means 0 0 0 0. That will be 0. So the first cell represents all zeros. So according to what is the term value of the min term, these values are represented in the corners. So we have 0, 1, 3, 2, 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11, 10. This is all according to the variables, and here we are not having continuity. It's only because in this sort of maps only one variable changes at a time. Both variables cannot change at the same time, or so many variables cannot change. It's only having one variable change from one cell to another neighboring cell. So let us have an expression y equal to a naught b c naught d naught, or a naught b c naught d, or a naught b c d naught, or a naught b c d, or a b c naught d, or a b c d. If we see that this expression has the first min term as a naught b c naught d, it means 0, 1, 0, 0. So if we see that where this cell it represents actually 0, 1, 0, 0 means 4, so it will be 4 cell, and accordingly all the terms according to that value they represent, they will occupy the cells. The second term has 5, 0, 1, 0, 1. The third term has 0, 1, 1, 0 means 6. The fourth term has 0, 1, 1, 1 means 7. The fifth term 1, 1, 0, 1, 13, and the last term 1, 1, 1, 1 means 15. All other terms are not present. So this sort of expression can be having 16 different min terms. But the min terms here present are only these 6 terms. So all these terms are present, so we'll write 1 in those cells, and all other cells will be 0. Then we'll start combining, and if we combine, we can have a square chord in the center, and another chord can be there because 1 or 2 ones again remain. So we can combine this not as 2 ones, but we'll combine it as a chord, because a chord minimizes 2 variables. So we'll make another chord, the horizontal chord, and this is a square chord, and the square chord actually vanishes 2 variables. The variable vanished on the AB side is A and A bar will go, and B remains in the horizontal direction, and in the vertical direction C and C bar will go. So D remains, that means BD is the minimized expression for this chord. And the other chord, we have the horizontal variables remaining and the vertical variable is going, and that is C will go with C naught and D will go with D naught. So only remaining is the horizontal variables, that means A naught B. So the solution of this expression is the simple minimization y equal to BD or A not B. We can see these all terms were represented with the expressions, the Boolean expressions, but we can represent the same as the ones are present at 4, 5, 6, 7, 13, 15. So we'll write the summation y equal to summation of 4, 5, 6, 7, 13, 15. We move forward with the expressions again, and if this expression is there with 6 min terms, I have placed them in the Karnaugh map and I have made the pairs and accord. So if we see that the solution is for the chord, it is BC, for one pair it is ABD, for the other pair it is ACD. Here we can simply get a circuit to implement this, the simple solution. Now let's move forward. See the minimize summation of 0, 1, 2, 8, 10, 11, 14, 15. You can get a Karnaugh map and they just place these terms inside. 0 term is present, 1 term is present, 2 is also present, 3, 4, 5, 6 or 7 are absent, then 8 is present, then 10 is present, 11 is present, 14 is present, and 15 is also present. Now we can make the chords and pairs. See that there are ones in the corners, so these corners cannot be paired, they can form a chord. So there is a corner chord and a bottom right chord, and then only one remains that can be paired. So the solution is over. If we see that the bottom chord in the right is representing C, A or AC, because B and B naught vanish on one side and D and D naught vanish on the other side. So the solution for this chord is AC, and the other chord, the bottom chord, the corner chord. In the corner chord, C and C naught goes in the rows and A naught goes in the rows, so it will be B naught, D naught. So the total solution, if we see, will be y equal to A naught, C naught, D, B naught, D naught, the chord, corner chord, and AC, the bottom right chord. We can change this, that this is end of the this is end of the notes. It will be a NOR simple, so it will be y equal to A NOR of A A or C or D. It's NOR of A, C, D. And it's also the AND of nots. It will be NOR, so it will be B NOR with D. And then we have the AC, so the simple circuit can be there for the solution implementation of this expression. Now let's take the examples having the expressions with do not care conditions also. So 7, 9, 11, 13, 14, 15 the terms, and now we have 5 and 10 as don't care conditions. So what we'll do now is a similar problem which we have already studied, but here in addition to this problem we have two do not cares for at 5 and 10. So what we'll do, we'll try to make chords. The 4 chords are formed, and the solution of these chords with the help of these don't care conditions is y equal to AC or BC or BD. So this is the solution, and the problem will be further solved with the help of the don't care conditions. So let's take this example again, but here the don't care condition is only now at one place at 6. Earlier we are having the don't care at 5 and 10, now it's only at 6. So we'll see the solution. The solution is further simple. Only one don't care at 6 has now reduced it further. So how it has reduced it further? You see that now instead of 3 chords we finished this in only 2 chords. So the 2 chords have the value BC AD. So the simple solution is BC or AD. So this is the implementation, very simple implementation. Here we have the problems. Now these are 7 problems as a home assignment for you. This we come to the end of this session. So wish you all the best. Thank you.